everyone, I'm back, and today we're going to be talking about codons and anticodons. So, to me, codons and anticodons were a pretty confusing part of the introductory biology course here at Berkeley. So I thought I'd make a brief video just showing exactly what are anticodons and what are codons, and do you find anticodons on DNA, do you find codons on DNA, what exactly is happening. Okay. So I drew these two things, these two bits of DNA here, and essentially on the two pieces of DNA we have something analogous to our anticodon. Now what that means is what that implies is that the mRNA is what carries the codons. Now if you remember back to introductory biology, AUG or methionine is the start codon for protein synthesis. Now that means that on the DNA that is directly opposite of it, what motif you see is actually a TAC on the DNA. So if we look here, we have a 3' TAC to 5', and let's just put this right at the beginning because that's where the mRNA is going to start transcribing from. Although results may vary, there may be things before it. Now on the mRNA, where the codon is, let me click here real fast. So the mRNA here carries the codon. There you go. Okay, so the mRNA carries the codon here. And so we would expect to see the AUG on the mRNA going from 5' to 3', meaning the 5' phosphate, then the A, then the U, then the G. And that's exactly what we see. Let me put that in. Oh. 5' phosphate first, then the A, then the U, then the G. And then here's a 3' end. Now notice that the AUG here is directly complementary to the DNA. I'm going to move this mRNA strand down real fast. So that means that when we bring this over to the ribosome and we have a tRNA that we bind it up to, the tRNA is not going to match this AUG sequence. Remember that the codon is directly on the mRNA. And that's important because lots of the times people get confused. They're like, is the codon on the DNA? Do I expect to see AUG there? No, the AUG is on the mRNA. So we have the AUG on the mRNA now. And what I'm going to do is I'm going to bring it over to our handy dandy ribosome. So this is going to be a ribosome, and I'll label that for you. Ribosome. And the ribosome doesn't have the EPA sites, but I'm just going to leave that for now. Okay, so we're here. We got a ribosome. And this mRNA here, bring it all over, is going to travel over to the ribosome. Oh, I don't want the TAC. This all is going to travel over to the ribosome. Now, as we start the peptide synthesis, this tRNA here is going to carry the methionine. So I could designate that with a little bubble. At the very top, that's our methionine there. Now, when the mRNA AUG binds to the anticodon on the tRNA, note the anticodons on the tRNA, so I'll label that too. Note that when the anticodon on the tRNA binds to the AUG, this methionine here gets removed, and essentially this tRNA can now enter the next site. So this tRNA binds to the next peptide, and this tRNA here would just simply move over along with the sequence. And likewise, the mRNA would move with it. over to the side. So just to reiterate, anticodons are on the tRNA. The anticodon analog is on the DNA. And essentially, the codon is on the mRNA. The AUG is always on the mRNA. So if you go looking and the biology question asks you, where do you see the AUG? You always write the AUG is on the mRNA. Now from the DNA, the results may vary depending on whether or not you're looking at this bottom strand here or this top strand here. But just remember that if you're looking at the template strand, it's going, and this top one's a template strand, that this is going to be directly complementary to the AUG on your mRNA. And that's all I got for today. Thank you.